Hello, welcome. Okay, so today we will be looking at the 2009 AP Chemistry for response question number 2 from Form B. This question has to do with kinetics, but first we need to look at what the question is all asking us and what the experiment all entails. Okay, so a student performed an experiment to investigate the decomposition of sodium thiosulfate. Sodium thiosulfate in acidic solution is represented by the equation above. Each trial, the student mixed a different concentration of sodium thiosulfate with hydrochloric acid, constant temperature, and determined the rate of disappearance of thiosulfate. Data from 5 trials are given below in the table on the left and plotted in the graph on the right. Okay, so for part A, we're asked to identify the independent variable in the experiment. The independent variable, again, is the thing that is altered or changed from trial, and experiment, or the thing that is tested. So looking at the table on the left, we can see that the initial concentration of thiosulfate is changed from trial. So therefore, we know that the independent variable is the initial concentration of the thiosulfate. Okay, so next we're asked to determine the order of the reaction with respect to thiosulfate. Specify your answer by using the information above. Okay, so first we want to just remember that the rate law is the rate times equals the constant K times the concentration of A raised to the M power. The M power is really what we're looking for, or the order of the reaction. But first we need to set a proportion. So we're going to have rate 2 over rate 1 equals K2 times the concentration of the thiosulfate raised to the M2 all over K1 concentration of thiosulfate raised to the M1. Okay, so now we basically just need to plug our information in. So looking at the data in trial 1 and trial 2, we are going to take the initial rate of the second one, so 0.030, all over 0.020, and then that equals, the rate constant is a constant, so we don't really need to worry about that right now, and that would end up canceling out with each other. However, the initial concentration is changed between the 2 trials, so we need to include that. So equals all over 0.050. Okay, and these are both raised to the M power. So after we solve this, we get down to 1.5 equals 1.5 to the M power. So looking at this, we know that the m would have to equal 1, because 1.5 raised to the first power is just 1.5. So now we know that this is a first order reaction. Okay, so now part C asks us to determine the value of the rate constant K for the reaction. Make sure you include units in your answer, and you need to show the steps that you arrived at your answer. So the first step is to set up the rate law equation. So rate equals concentration equals K times the concentration of the thiosulfate. And in the previous part, we just figured out that it's a first order reaction. So we just have the 1 out front. And then after that, we just need to plug our values in to be able to find K. We also need to rearrange the equation so it's easier to see. So we're going to have K equals the concentration of thiosulfate all over the rate. Okay, so I'm just going to plug in the information from trial 1, because rate constant is a constant and will be the same throughout the whole reaction. So we're going to have the K equals the initial concentration, so 0.050 all over 0.020. So then we get K, and this is molarity, and this is molarity per second. So then we get that to equal 0.40 inverse seconds, or per second, because constant for first order reactions have a label of just inverse seconds. Otherwise, there is another way to solve this problem as well. You can find the slope of the line. So rate is really just the change in distance over the change in time. So we could just set it up as K equals the change in distance. So I'm going to use the information from your trial I'm just going to use information from trial 1 and trial 5. So back down here again, we have the change in distance. So K equals the 0.051 minus 0.020, which is in molarity per second, all over 0.125 minus 0.05. Okay, so which is in molarity. So then we also get this down to, for the rate constant, to 0.4 inverse seconds. Okay, so moving on to the next part. So in another trial, the student mixed 0.1 molarity sodium thiosulfate with hydrochloric acid. You need to calculate the amount of time it would take for the concentration of thiosulfate to drop to 0.020 molarity. So we need to use the integrated rate law for this, and for first order reactions, it is the natural log of the final concentration of A minus the natural log of the initial concentration of A, and then this all equals negative negative rate constant times time. Okay, so now we are really just solving for the time. So we can eventually rewrite it and combine the natural logs, and then also plug the information we know in for the concentration of the thiosulfate, which is really the A in both of these. These are just thiosulfate. And then also the rate constant, which we solved for in the previous part. So we're going to have the natural log of the final concentration of A, so that's the 0.020. And when you have natural logs and subtract them, you can put them into a fraction, minus the initial concentration, so 0.1, and molar, and then that equals negative K, so K, which we just solved for, was 0.40 inverse seconds, and then times time. Okay, so then we eventually get down to negative 1.61 all over 0.40 inverse seconds. And then we have that all set equal to the time. So we eventually get that simplified down to the time equals 4 seconds when the concentration of the thiosulfate will drop to 0.02 molar. Okay, so for the final part, we are asked to, on the graph above, sketch the line that shows the results that would be expected if the student repeated 5 trials at temperature lower than that during the first set of trials. So we know that temperature speeds up a reaction, and with a lower temperature, we're going to have a lower rate of disappearance of the thiosulfate. So on the y-axis over here, we have the initial rate of disappearance. So the rate is going to be lower. So we're going to start at a lower point down here. And then because the temperature is lower still, the rate of the reaction is going to continue to be lower than that of the previous sets of trials. So the slope here is also going to be not quite as steep, because at each new initial concentration of the thiosulfate, we're going to not have as much thiosulfate disappearing, so the y wouldn't be quite as high. So we're going to have a less steep slope and a lower value for the starting y-axis.